Hi, welcome to CAP, Quantum Academy for Physics. I think this is our third lecture on units and dimensions. Right? This lecture will also useful for both the intermediate first year students as well as ECET students. So before trying to solve or before trying to find out the dimensional formula for physical quantities, you have to know the definition and the mathematical formula for those physical quantities. So please, before going to find out the dimensional formula, you please go through the definitions and the mathematical formulas for those physical quantities. Okay, for example, physical quantities like force, volume, density, moment of inertia, and momentum, linear momentum, angular momentum, friction. All these are the physical quantities. We are going to find, for all those physical quantities, we are going to find out the dimensional formulas. Okay, and I think we had solved, we had find out the dimensional formulas for force, acceleration, angle, and angular displacement. Okay, in today's lecture we will find the dimensional formula for angular velocity. So what is angular velocity and what is the expression, mathematical expression for angular velocity, you have to know before going to find out the dimensional formula. Okay, angular velocity, the expression is the mathematical expression is angular displacement by time t. Okay, angular displacement is measured in terms of radian and the symbol is rad, and time is measured in terms of second and the symbol is s. Okay, now this can be written as rad per second, that is rad into s power minus 1. Now coming to the dimensional formula for angular velocity, we will write the dimensional formula in terms of mass, length and time. Okay, we are writing the dimensional formula in terms of mass, length and time. Okay, is there any mass in this equation? In this equation, is there any mass? No. So you have to write m power 0. And length, coming to the length, there is no length, so L power 0, and time s power minus 1, so t power minus 1. The dimensional formula for angular velocity is m power 0, L power 0 and t power minus 1. Okay, so the dimensions for angular velocity are 0 in mass, 0 in length and minus 1 in seconds. Okay, we will go to the next one, angular acceleration. Coming to the angular acceleration. What is angular acceleration? Change in angular velocity. The expression is change in angular velocity per time. Okay, then what are the units for change in angular velocity? Units for change in angular velocity is rad into s power minus 1. Okay, change in angular velocity. What is angular velocity? We have here rad into s power minus 1 divided by time t. T is measured in seconds. Okay, now this can be written as rad into s power minus 2. Here you have plus 1 and this will go to the numerator. If it move to the numerator, then this plus 1 will changes to -1. Okay, so we have -1 plus -1 is s power -2. Okay, and what are the dimension? What is the dimensional formula for angular acceleration? There is no mass, so m power 0, no length, L power 0, and time t power -2. So the difference between angular velocity and angular acceleration, the difference of dimensional formula for angular velocity and angular acceleration is, here we have t power -1, and in this equation we have t power -2. So angular velocity and angular acceleration dimensional formulas are similar in mass and length. The question for ECET exam is coming to the dimensional formula, what are the similarities for angular velocities and angular acceleration? Answer is they are same in mass and length and different in time t. Okay, next coming to the third one. Inertia. What is inertia? Inertia is nothing but mass into radius of gyratia square. Radius of gyratia square, that is mass into r square. I, moment of inertia, is denoted with capital I, and it will be equal to mr square. Okay, mass, m is mass. Okay, m is mass. It is measured in terms of kg. Okay, but there is no need of writing here units. Okay, mass, and the radius of gyratia is measured in terms of length square. Okay, now dimensional formula here. What is the dimensional formula? You have mass, so m power 1, and length L square, and there is no time here, so t power 0. The dimensional formula for inertia is m1 L power 2 t power 0. Next, coming to the angular momentum. Any one of you please write the expression for angular momentum. Try to write expression for angular momentum and derive the dimensional formula for angular momentum. Angular momentum is nothing but angular velocity into moment of inertia. Here write completely moment of inertia. So what is the dimensional formula? We just derived the dimensional formula for angular velocity, right? Angular velocity is m0 L0 t power -1, and for inertia we have m L square t power 0. Okay, now you just multiply. If the bases are same, power should be added, you know that. So m power 0, m power plus 1 is m power 1, L power 0, L power 2 is L power 2, t power -1, t power 0 is t power -1. So coming to the angular momentum, the dimensional formula is m power 1, L power 2 and t power -1. This is the dimensional formula for angular momentum. Okay, so why we are writing only m into L into t? We are representing the derived physical quantities in terms of base physical quantities, that is fundamental physical quantities. Okay, here dimensional formula, what we are doing here actually for dimensional formula is nothing but we are representing the derived physical quantities in terms of fundamental physical quantities. Okay, Next, after angular momentum, linear momentum, I think it's over. Okay, we will go for next one. Torque. Torque is equal to moment of inertia into angular acceleration. Torque is, next one is torque. This is number 4. Torque is number 5. So what is torque? Inertia, moment of inertia into angular acceleration. See, I am not explaining every physical quantity in my lectures. Why? Because we have very less time for preparing for ECET examination. We have left with, this is March, April, May. We have only 2 months for preparation for ECET. You have to prepare for remaining subjects also. I will also teach maths here in my videos or in my lectures. I will also teach you mathematics. So we have very less time. So that is the main reason why I am not explaining every physical quantity. I am just giving the expression for a physical quantity actually. But I will try to make a video for explaining the physical quantities, and I will also give a definition for each physical quantity. I will try to make a video. Okay. Now next, torque. Torque is inertia into angular acceleration. What is the inertia? We had already derived the dimensional formula for inertia. It is m power 1 L power 2 t power 0. And what is angular acceleration? We to derive this m naught L naught t power minus 1. Angular acceleration dimensional formula is m naught L naught t power minus 2. You just multiply this. M power 1 into m power 0 is m power 1. L power 2 into L power 0 is L power 2. And t power 0 t power minus 2 is t power minus 2. This is the dimensional formula. m L square t power minus 2 is the dimensional formula for torque. Impulse. One more is impulse, and then after pressure, work and power. We will derive the dimensional formula for these physical quantities. You please try to solve. Okay. Impulse. What is impulse? Impulse is nothing but force. The expression for impulse is force into time t. What is force? We had derived just now, m into L into t power minus 2, and you left with the time t. Now you just multiply this one, m into L into t power minus 2 t power plus 1 will become as t power plus 1. Okay. So m into L into t. T power minus 1. It's a t power minus 1. Minus 2 plus 1 is minus 1. Okay, next pressure. What is pressure? It's a force per unit area. It's a force per unit area. What is force? M into L into t power minus 2. What is area? It's a length square. Okay, L power 2. Now you just add you just add the powers. So length L power plus 1 minus 2 is L power minus 1 into t power minus 2. So the dimensional formula for pressure is m into L power minus 1 into t power minus 2. Okay. And what are the dimensions? If the question is what are the dimensions for pressure? It is 1 in mass, minus 1 in length, and minus 2 in time. Okay. Just don't confuse with the dimensional formula and dimensions. Okay. And work. What is work? Work is force into displacement. Force into displacement. Okay, if a force is applied on a body, then the body will be displaced, then the work is done on that body or object. Force into displacement. What is force? M into L into T power minus 2, and displacement is measured in terms of length. Okay, length L, and we just multiply M into L into plus 1 will be plus 2 into T power minus 2. M L square T power minus 2 is for work, dimensional formula for work. And coming to power. Power is work done per time t. Work done per time t. So work, what is work? What is the dimensional formula for work? M L square T power minus 2 by time t, which is equal to M into L power 2 into T power here plus 1. Okay, plus 1, when it comes to numerator it will become minus 1. So T power minus 3. This is the dimensional formula for power. Okay. And next we will solve the dimensional formulas for energy, Boltzmann constant, acceleration due to gravity, and universal gravitational constant. What is energy? Energy is nothing but it's a kinetic energy or a potential energy. If I take a kinetic energy half mv square, what is mass? Mass is measured in terms of kg, and we represent the mass with capital M. And what is velocity? Dimensional formula for velocity is L into T power minus 1. It's minus 1 or minus 2? Just please check it. And you have square, v square, so L T power minus 1 whole square. Now the dimensional formula for energy is M into L square into T power minus 2. The question will be like this. The dimensional formula similar to energy is, and the options are work, Boltzmann constant, acceleration due to gravity, and universal gravitational constant. Answer is work. The dimensional formula for work is also ml square T power minus 1. Okay, and coming to Boltzmann constant. Boltzmann's constant is energy per temperature. Energy per temperature. And what is the dimensional formula for energy? ml square T power minus 1 by temperature is measured in terms of Kelvin, K. Now the dimensional formula for Boltzmann constant is ml square T power minus 2 into K. You have to K power minus 1. We are using only fundamental physical quantities, not derived physical quantities and supplementary physical quantities. Okay, we are writing the dimensional formulas by using fundamental quantities only. Okay, if there is no fundamental quantity in the given expression, okay, then that derived physical quantity is said to be dimensionless. It have units, but there are no dimensions. Okay, and coming to acceleration due to gravity. Acceleration due to gravity. What is acceleration due to gravity? This is given as g, small g is equal to capital G into m by r square. So acceleration due to gravity is represented with a small g, and capital G is universal gravitational constant into mass by r square. Okay, the distance between the masses, two masses. Okay, and G, capital G, will first of all we will derive the dimensional formula for universal gravitational constant. Okay, then we will substitute this dimensional formula in this equation. Force F is equal to force according to Newton's laws. The force between any two masses in the universe is given as F equal to G into m1 m2 by r square. This is mass 1 mass 2 by the distance between these two masses. Okay, and from here this capital G can be written as F into r square by m1 into m2. And what is the dimensional formula for force? What is the dimensional formula for force? M into L into L into T power minus 2. This is the dimensional formula for force. Okay, and you please always use the square brackets. Okay, while deriving the dimensional formulas. Why? Because the dimensional formula will be represented in square brackets only. Please, you just don't forget to write it. And this distance is measured in terms of length, L square by mass m1 into m2, that is m square. Okay, now you just solve this. And give me the final answer. M power 1, m power minus 2 will be m power minus 1 into L into L square is L cube into T power minus 2. This is the dimensional formula for universal gravitational constant. And coming to the acceleration due to gravity, you just substitute here. I'm just rubbing this. So you just substitute here. What is capital G? M power minus 1 into L cube into T power minus 2 into M, capital M, by R square. Okay, m power minus 1 into m power plus 1 is m power 0, L cube into L power minus 2 is L power 1 into T power minus 2. So m naught L T power minus 2 is the dimensional formula for acceleration due to gravity. So there is if you want to multiply the dimensional formula of two different physical quantities, you just use square brackets, not into. Okay, not into. You just use square brackets. Okay. And the next one is density. I will derive the dimensional formula for density, and then value, and then pressure. What is density? Density is mass by value. So to derive density, first of all we have to know the dimensional formula for value, so that I will write the dimensional formula for value initially. Okay, volume is length. The expression for volume is length into breadth into height. Okay, length, breadth and height are these three are physical quantities which are related to length only, right? So now L, you have length L, breadth L and height L. So the dimensional formula is m naught L cube T naught. There is no mass and no time, so the dimensional formula for volume is m naught L cube T naught. L power 1, L power 1, L power 1 will be L cube. Now you just substitute in this equation. Okay, mass capital M by volume is m naught L cube T naught. Okay, now mass m by m power 0 will be m and L cube T naught. This is the dimensional formula for density. And coming to pressure, pressure is force per area. And what is the dimensional formula for force? m L T power minus 2, m L T power minus 2, and area is L square. Okay, L square. So m into L by L into L power minus 2 will be L power minus 1 into T power minus 2. This is the dimensional formula for pressure. Okay, I will end this lecture here itself, and we will solve few more dimensional formulas in my next lecture. Here I just derived few basic dimensional formulas only. We will use these dimensional formulas for deriving various dimensional formulas of derived physical quantities. For example, here I used volume to derive the density. Okay, and I used force for deriving dimensional formula for pressure. Okay, these are very basic, you have to know. Okay, you just learn, please go through these dimensional formulas and try to remember so that you can directly apply these dimensional formulas for deriving various dimensional formulas of various physical quantities. Okay, I will end my lecture here itself.